It's not very often that I get an email from the Kingdom of Denmark. My first inclination was to think that maybe it was related to a Nigerian scam, potentially, but then it said something about groundwater management, and it was technical enough and sophisticated enough that I thought, oh, this is actually a real thing. So I did indeed receive an email from the Kingdom of Denmark several months ago, wanting to have a discussion about groundwater management in Texas, that they were new to the state and wanted to learn about it. And in the process, I've learned a great number of things about groundwater in Denmark. And we thought it would be great to share that with you as well, because we have some commonalities that you may not have assumed. So join me in welcoming Jacob Vind, who is the Counsel General here in Texas and the head of the Danish Water Technology Alliance. Let's welcome him this afternoon.
Thank you.
Welcome.
Just gonna put the timer on here. So a Nigerian scam artist. So if I can ask all of you to take out your credit cards. On the next slide, there's going to be an account number, and it's just a small payment. It's because I have a very rich aunt that passed away. So if you just, all of you, transfer $100, you'll be part of a lottery to win this amazing sum, and you can fund all the wonderful things you want to be doing for your groundwater districts. So yeah. Okay, thank you, Sarah. I'm very honored to be invited here. I think one of the marks said that he's used to being in the dumbest guy in the room. I'm 100% sure the dumbest guy here. I'm not a hydrogeologist or a lawyer. I'm a diplomat. Diplomats are known for thinking twice before not saying anything. So that's my main competency. But I will try to say a little bit about groundwater management in Denmark. And from hearing you all today, and also from previous dialogue with Sarah and others, I think actually there are some commonalities. I also know that you don't mess with Texas, so I'm not here to tell you all what to do. I'm just going to talk a little bit about what we've been doing, and I'm going to let all of you decide if that's relevant or not. So just take this as a chance to see a totally different perspective, and please don't take offense if some of it is simply too weird, because it's a bit different. Okay, so first of all, the reason I'm here, so apart from being the Danish Consul General in Texas, we just opened a consulate here this year. So Denmark is investing heavily in Texas to strengthen ties between Texas and Denmark, which is nice. I do run a water technology alliance in the whole of the US. We work in these areas that you see up here, a number of water technology related areas. Of course, today my focus will be on groundwater management, but that's just to say this is a larger US-based alliance. And you're all thinking, why are you all here? I mean, what is the Kingdom of Denmark? What's the Danish water technology? What are we doing? And the short answer to that question is that the Danes, we want to be known for more than the Little Mermaid in Copenhagen, or Lego, or Danish pastry, or whatever you might associate with Denmark. We're actually quite proud of some of the achievements we've done in water, and we're also very ambitious in terms of being a global leader in water. And we're a small country, I'll get back to that, and the only way we can sort of be global leaders is to collaborate. We're way too small to do anything on our own. And that's why I write not Nigerian scam artist mails, but actually, interested emails to people in Texas to try to understand. I'm not there yet. I've learned a lot today already, which I appreciate. So just to highlight the fact, this is our Prime Minister, and this is a great Lego city we built, and you can see the aquifers are there, and it's a whole water cycle, one water Lego village we have. I'll try to bring it to Texas sometime. It's pretty cool. But just to say, Denmark, we want to work globally with water. So, and one last thing. I know Americans love the beautiful Danish town name of Middelfart. So one thing I do in the capacity of this Water Technology Alliance is we have the chance a few times a year we bring US water folks to Denmark on fact-finding trips. So this is actually might be the best chance in your life to get close to the town of Middelfart. Okay, so a little bit about Denmark. We're a constitutional monarchy. We have right now a queen. We're that few people that we're counting the decimals. So we're 5.6 million people, 16.5 thousand square miles, so a little bit larger than the Edwards Aquifer area. 2/3 of our lands are agricultural lands. We produce 28 million pigs, so the pigs per person ratio is quite high. I was just on the phone with my wife. She was yelling, so I think it's 28 million.1 or +1. We're 100% groundwater, so we have surface water, but we only use it for recreational purpose, so all our drinking water is groundwater. Average annual precipitation around 30 inches. The average Dane consumes a little less water than you do here in Texas, around 28 gallons per person per day, which has come down a lot over the years. And then what might be very interesting to you guys is, so we're 100% groundwater. We have 2/3 of our lands, agricultural lands, and we have a policy of not treating the water. So we don't treat it. We pump it out of the ground, we oxidize it a little bit and run it through a sand filter. And most Americans I bring to Denmark, they don't dare to drink the water after they hear we don't chlorinate it. But we don't. It's a national policy. It's not because we don't know how to, but we've decided to put an emphasis on keeping the source clean. And then last but not least, it's a decentralized system. So that's just to give you some background on that. Very shortly, just to say what we in general are quite proud of is that since the 80s we've managed to almost, not quite, but almost double our economy, at least have a nice economic growth, and at the same time actually reduce water consumption. So that's an important thing for us. It's not all rosy things. I think one of the previous speakers talked about these crises coming up, and I normally call them windows of opportunity. When something bad happens, that's when we all, and especially the politicians, start to act. And in Denmark, this is 20, 30 years ago, we started to see a lot of issues with our groundwater. We had decreasing groundwater tables. We had saline or saltwater intrusion. We had a lot of surface water, groundwater interaction, lack of stream flows in the summer, and then a ton of water quality issues. It's very interesting to hear from the Edwards folks. So, of course, the ag-related ones, nitrates and pesticides, which is still something we're battling a lot with, but also point source stuff from industry and old dry cleaners, gas station, all of that stuff. And when you have a policy not to treat the water, you really, really, really need to act fast. So we had a kind of a crisis with these dead fish popping up all over the papers. Of course, that's the nutrients. So a big issue, just more pictures to showcase that. So what we did was we came up with a groundwater management program to actually give us a new way of managing groundwater in Denmark, because it was clearly not sustainable what we were doing, neither in terms of quantity or quality, although once again quality being the main problem. So this is just to show you the sort of the policies of the framework. So groundwater is a common good in Denmark. So once again, a little bit of a difference between Denmark and Texas here. So no private property rights. It's a common good. So people are permitted, it's a public good. As I said, prevention of pollution before cleaning, decentralized abstraction. We have minimum treatment, I already said that. And then there's a lot of focus on energy. So we really put a lot of emphasis on running efficient well fields and designing systems that are energy efficient as well. The sort of the legislative framework is a Water Supply Act, it's an Environmental Act, it's the Planning Act, and then it's the Water Sector Act, and that's the last one is more financial. It's actually kind of interesting, but I'm not going to go into it here. But what I will say is that we talked about integrated water management, and this framework really requires that we look at both the groundwater and the surface water and the whole interaction. So that's part of the sort of the groundwater management in Denmark also pertains to what goes on at the surface. Okay, so as I said, so what we did is we came up with this program. It started in 1999, where our problems had become so big that we needed to act, so we passed a law. The national and started the National Groundwater Mapping Program. It's once again a big difference here. It was financed. It's done now. We finished in 2015. We believe we have a sustainable model in place. But it was financed by water consumers at around 8.2 cents per acre foot. I did a rough calculation, so it's roughly $5 per Dane per year that financed this, and a lot of this was some of the issues that you're talking about, collecting a lot more data and coordinating regionally and stuff like that. And once again, that's sort of the political framework in Denmark. You can do it like that. If you look at the water prices, it's just a tiny bit of the total price, and if you look at what Danes spend in a year on stuff, it's nothing. So there was not too much complaint about this because nobody actually realized they were paying towards a groundwater management program, which also pertains back to the trust. There's a much higher trust level between private citizens and public authorities in Denmark. So we're the government, we're here to help. A Dane will actually think, oh, well, that's good, thank you, and not pull out the shotgun. So just a few more words. What we did is we delineated sensitive abstraction and focus areas. So started looking at the whole country and saying we can't do it all at once. Let's focus on the areas that are really interesting here. Everything is done from the ground up, from the local level. So the municipalities do action plans and implementation. That's an important part, and it's very similar to here. Of course, the terms are different, but it's the same mechanism. We had funding for forestation and subsidy schemes to fallow land, stuff like that. It doesn't have to be the same here, but the fact that there was financing to actually compensate farmers or industries or others that couldn't continue to keep doing what they were doing is an important part of this. We implemented nationwide databases and formats. I'll get back to that. Extremely important. And the total cost for these roughly 15, 16 years was around $400, $500 million. That, of course, does not cover the operation that goes on now, but it covers coming from a real bad situation into a sustainable model and having the necessary standards, databases, technologies, and organizational setup. So that's just to give you an idea. Of course, it's hard to calculate precisely. Just need to check my time here. Okay. I don't know what happened with the formatting here. Anyway, it's super important to say that everything that went on in Denmark, it was a collaborative effort. It's the same I see here. So the Danish EPA had the overall management of this program and the overview, and also provided the funding through the taxes. So they collected the taxes and trickled it down mainly to the municipalities that had, the local responsibility. But of course, a lot of it ended up also funding consultants, which kind of like I also see here are doing a lot of the actual work because it requires specialized knowledge in different fields. Some of the money was spent on universities. We had to educate new people because we needed new competencies to conduct the actual work. We had to work on standards. We needed common data standards because, as you may or may not know, it's very hard to look at a thing holistically if you have 100 million different data sets. And then technologies as well. A lot of research projects were funded, and a lot of technologies actually came out of the universities through this program. And then last but not least, our geological survey had and still has oversight of the standards and maintain the databases, which are a critical aspect of the Danish groundwater management. I'll get back to that. Sorry, this is a heavy one, but I thought it was important. So groundwater abstraction is, once again, it's a public good. It's licensed space. You typically get 20, 30 years of a license, and as long as you're not impacting negatively your neighbors or anyone else in the area, you can continue on that permit. If you do, you have to reimburse. We have a polluter pays principle, so if you're drawing too much water in terms of regional aspects, you have to compensate. That's the rule. And then, once again, going back to integrated water management. So the licensors must adhere to physical planning, water supply, action plans, regional, national planning, and EU directives, habitats, and then be subject to environmental impact analysis. So we're looking at the whole gamut. We're even looking at urban development and everything. So everything goes into these plans. So it's really important to note that it's not just water quantity or quality. It's surface water, and it's habitats, and it's urban development done in the municipal office for that. So it's really a holistic approach that is being integrated here. And once the municipal council has approved these plans, it's being overseen by the EPA, and the implementation is done in collaboration between the municipality and the water utilities. Okay, so getting a little bit more into the weeds. So this was the framework or the structure. So what did we actually do, and what did we come up with to have a sustainable groundwater management setup in Denmark? So this is the sort of the process we go through every time we encounter we did encounter a new basin. These are the processes. So we'd always start with data greedy. So we'd always start looking at collecting as much existing data as we have. That can be troublesome and tiresome as well. And then looking locally at, getting the people that know the local geology, the local history, the local conditions, getting all of that data and info in there from the beginning before we take any steps. Then what we've done is we've had a tremendous amount of success with geophysics. I haven't seen too much of that here in Texas. I'm going to come back to that just to show you the value, at least in Denmark, of applying geophysics, not as a standalone solution, but in conjunction with the more traditional hydrogeological disciplines. Then we would move on to drilling, logging, and pump testing, and moving on to geochemical mapping to get all these different kind of data sets. And then in the end, integrating all of those in a hydrostratigraphic model. This is really a high fidelity model. It's not a flow model. It can't do what a flow model can. It can't predict scenarios, but it can give you a very accurate picture of your the area that you're working on, and allow you in a flexible way to work with that. That moves into a flow model that's a lot more simple, but as long as the flow model is based on the hydrostratigraphic model, you should be able to, not 100%, because nothing is ever 100%, you know that better than I do, but you can trust your flow model a lot more than, once again, I'm talking about Danish experiences, than what we could before. That moves into the whole land use, pollution zones, because we really pinpointed areas of particular interest here, into vulnerability assessments. And then in the end, this turns into the desired future conditions document report here. We call it an action plan, but it's more or less the same, except that in Denmark it also entails these planning issues and not just the groundwater side of things. So that's the whole process we developed. It works really well. In the center, you'll see a lot of databases, and that's a super important point, is that we've created an open, publicly open database set up so everyone can access all data at all times. Really important, and we invested a lot of money in it, but it's paying off big time. So I'm going to talk a little bit more about that. So two things I want to emphasize: geophysics first and foremost. So why do we say that really helped us quite significantly? So a 6-inch borehole represents around less than 1 million of an acre. So it's kind of like looking down into the ground with a straw. You can, of course, see very precisely what you're looking at, but what goes on 100 feet to the right or to the left, we don't really know. We can make some good guesses, and the more we know, the better guesses we can make, of course. So this is a picture from Denmark, from the early days of our groundwater program. And this is taken from a flow model, and imagine you're hovering and looking down, and the dark colors, the purple colors, are the paleochannels. So those are the deeper areas. And the problem with this model is, so the basis of this, it's around 7 by 7 or 8 by 8 miles. So it's not a huge area. We had the information that went into this model was a little over 500 wells. You can see all the wells are the black dots. And this calibrated very nicely into a flow model. I mean, a beautiful flow model. The problem was that we had water disappearing out of this area, and the flow model could not explain where it went. And we were kind of frustrated with that. So what we tried was to apply geophysics. There was a huge discussion in Denmark between the hydrogeologists and geophysicists about what to apply and what not to apply. But in the end, we applied geophysics. So this is the exact same subsurface. You're still looking into the subsurface here. Exact same area, 8 by 8 miles. We're still using the information from the 500 wells. And then we've done 1,400, what is called time domain electromagnetic. So it's a ground-based geophysics tool developed in Canada, I believe. And as you can see, what we mainly got here is a lot more detail, but also the discovery of a paleochannel that we, for some reason, hadn't caught without the geophysics. So that's the one. I don't know if that's good. Yeah, but that's the one in the middle that kind of gave us an explanation of where the water was going. So what we talk a lot about is, once again, being data greedy, getting more data. We're not discharging the well data. We're still using that, especially for ground proofing. It's super important. But getting this amount of data allows you to make a lot better sense of what you're looking at. And once you have a lot better sense of what you're looking at, you're also able to make more informed decisions. So, and that, in the end, that's what, groundwater management, in the end, is about making better decisions, whether you're in Denmark or in Texas or someplace else. So just to elaborate on that, so during these 15, 20 years, we've not developed, because a lot of it we've adapted from other countries, but we've utilized what we will call a geophysical toolbox. And as you can see, there's different depths, there's different applications. We've had a lot of success with the one in the upper right corner, the dual EM, which is a quad bike that pulls something. It's upper 30 feet. And then the SkyTem solution, which is a helicopter one. It's great because it covers a lot of ground. It can go up to 600 miles a day. You can cover a lot of ground. It's expensive, but if you want to, as we did in Denmark, after seeing these results, really want to cover larger areas, it's a super cost-efficient way. So just a few examples of that. You're going to get the slides, and I don't have time, but there are two very good videos here of a project in California and a project in Nebraska applying this airborne geophysical technology. So I would encourage you to look at those if you have the chance. They're very interesting, 5-6 minutes long. So just to say, this is a technology that was developed in Denmark out of the groundwater program. So it's similar technologies are used a lot for mineral exploration, but this one is developed specifically for groundwater. And this is not a specific case, but the next picture is. So once again, as I said, a borehole, it represents something. So these are samples from 400 feet deep. I've tried to put on what you see here. So you see some till and some clay and different stuff. But what do you put in a well here if you need this to site a well? Of course, you could make guesses if you know the area. But the point is, once you supplement this, so this is once again the same map. So all the black stuff here is the flight lines of the helicopter. So once you supplement that with the well data, You can clearly see that this is a paleo channel. You can even see some of the channels feeding into the paleo channel here. And this is at 400 feet. It's not too deep. We can and have looked a lot deeper than this, but it gives us a tremendous amount of understanding of what goes on in an area that we're not able to look at otherwise. And then for the more simple stuff on the surface, there was a very good question earlier about how to handle stormwater and how to capture some of that. We've used this technology for that. So this is a specific case here I want to show you. So this is just it's a small area, 1/2 mile by 1/2 mile or something like that, maybe a little bit bigger. It's an urban area, development area, and we want to put in housing here. It's outside of Denmark's second largest city. And you can see the color codings here. So the red and the purple is sand and gravel, and the yellow and the green is clay. And because we want to infiltrate water as quickly as possible, of course, we want to put a recharge pond or whatever we're putting in a place without too much clay. So, you can see on the right here, so we're at surface level. I'm just going to show you what happens when we go down, because looking at this, the only place you shouldn't put in a recharge pond is on the upper right corner, otherwise you should be good anywhere. But if we go down, you can see the marker moving down slowly here. It becomes quite obvious that you need to, if you are putting in a recharge pond or a water diversion facility, it should go in the southern part. And this is work that is done in a work day and applied in small projects all over the country. So just a very good way of course you don't get to see too deep, so you really need to be interested in the upper 30 feet. Okay, so that was the geophysics. Just a couple of examples. I know I'm moving fast, but I have to cover 20 years of groundwater management in not too much time. So I'll move on to the data management, which is in the middle here. So what is important to say about that is we decided early on to have open standards, open and standardized data. And what you can see here is that we have the green one is a borehole database. So all wells in Denmark are in a publicly available database. We can access it from here. I don't have my cursor, but we can access all Danish wells from here. I'll show you a few screen dumps. We have all the seismic data, all the borehole logs. In another one, we have reports, all consultant reports that have been done over the past 30 years are in an open database. So when you change consultant or something happens, you can just pick up whatever was there before. And the same with models. The Edwards aquifer talked about before, this iterative process. And we want to keep it iterative even though we are changing consultants. So all the models are out there as well, open, publicly available. You have to be certified to put data in, but everybody can take data out. And the yellow stuff is software that we developed to connect all these things, because the real gist here is to integrate data. We need to integrate all these different data sets. It's nice to have big data sets. We all like that. But we also know that once we start to look at them, it's hard to, how do you put them on top of each other? Because that's really where the greater understanding starts to arise. So in terms of the best thing to do would to do a live demo, just show the well database, because it's quite nice. And it would give me a chance to do a Steve Jobs thing, and you would all be, wow, that's pretty amazing. But the problem is, from personal experience, this is kind of, the likely scenario. So I'm going to skip that. It's not, as I said, I'll send you the link. I'll just show you this real briefly. So this is the report database. So basically, you see a map and you zoom in on any area, and you simply get a link base. You can click all the links. You get PDF reports. It's super nice, especially if you are a groundwater district and you don't want to spend a lot of time and money on re-educating new consultants, or don't want to have too much standing on the shelf in terms of paper. This is the well database, so I just want to show you this. So once you click, these are all the wells in Denmark you see here. And then when you zoom in, you can start to see that, yeah, they're actual well points. Then we zoom more in, and then you can, so I just clicked on one here. You'll see they pop up with a link. There's some different stats about them here. You can see the depth and their identification number. If you click the link, you get onto a specific site where you can see the well location, you can see the lithology, you can see that this is the driller's report that comes up as a PDF, but it's all there in numerical form, which is super important because you want it not only as a PDF. It's nice to be able to print a PDF, but you want the numerical data because the models feed on that and not PDFs. So all of that is there, and I strongly encourage you to, once again, to click the link once you get this presentation, because there's a lot of fun stuff for people who like groundwater to look at. You can really, you can see a lot of data. And the last point I want to make here for Denmark and our experiences with groundwater management is digital data. We started out in the late 90s with these handmade cross sections and layers that were digitized and gridded into Surfer. And it's okay to do a handmade drawing. The problem is when you have this iterative approach and you want a second opinion or something different or another angle or another area, it takes too much time. So we invested a lot of money in developing and purchasing internationally software that can integrate data formats. So you simply take any terrain. The green stuff you see on the first one is just a terrain model. That's all there is in it. And then we can pick from all these databases that I showed you before. We can collect. It takes 30 seconds to collect all the. You can put in all the wells. You can put in all the geochemistry. You can put in all the geophysics. And all of a sudden, in 5 minutes, you have all your data integrated in the same 3D environment. And this exports into the flow models. So you're working in that until you feel like you have an adequate understanding, and then you generate the flow models out of that. That has been super important. And we've done that for the past 5 years or so. And so I put in the future. The machines are taking over. So the next step, we're working actually on a project with Stanford in California to actually have machine learning, because we also know that it's hard to make sense of all this data, even though we have it integrated. So we are using computational logics and algorithms to understand. So we have a number of authorities here. So if we see this kind of clay, what does that mean? If we have a soil directly on top of that, that must 9 out of 10 times that means it's this kind of till or whatever. So using that kind of artificial intelligence is really what we're working on now. Okay, so once again, I'm not going to go through this because this is I spoke to a lot of colleagues, and part of this Water Technology Alliance is that we have Danish water utilities, your colleagues, are part of this. They're coming over here on a regular basis. We have the Danish EPA, who's the main responsible party for this program, coming over here once in a while. So I spoke to these guys and tried to get some of the best recommendations from our experiences, good and bad. We made a ton of mistakes, but these are some of them. So take a look at them. I'm in Houston. I'm not going anywhere. Denmark is here to stay. We want to build sustainable collaborations, and we have to behave well, so hopefully we can provide some inspiration, and I'm happy to also bring people that actually know what they're talking about and not just me, so that you can actually have a real conversation and not just a diplomat standing here. So I have one last slide, which it's just from personal experience. I've been here. I don't know if you have, but it's just it's going back to we talk a lot about money also. I hear this all the time today. So it's super expensive to collect all this data and get this information and make sense and get to the point where you can make these decisions. But we really have to remember what's the cost of not doing that. that's something we need to ask the politicians, at least, is that it's fine to have, and I love the MERS approach at looking at, economic efficiency in everything we do, but we also have to factor in the non-scenario. I mean, what's the cost of, it's fine that we have 3 scenarios of proactive action that have different costs, but what's the cost of the one we're not talking about, which is not being able to do anything because we don't have any funding? So that's based on Danish experiences. So I don't know if you have any questions. I spent a little bit too much time, not too much. And there was only a few people sleeping, so thank you for that.
Are we on? Yeah. The aquifers you're dealing with over there, are they primarily like alluvial? And if so, are they consolidated, unconsolidated, or can you characterize those for us?
I'm not 100% sure what alluvial means, I'm sorry. But I can tell you...
Gravel, sand?
Okay. So it's different. I mean, so the eastern part of Denmark is totally limestone.
Okay.
So that's one area, and the next one is a bit of a mixture, and then the western part of Denmark is totally sand and gravel. So because we had the ice age, and the ice came down from the north and basically stopped right in the middle of Denmark, which has created kind of an interesting geological setup. And the west part of Denmark, where all the sand and gravel is also where the main part of the ag is. So that's why we have extensive issues with nitrates and pesticides, because it just seeps right in.
Yeah, I was guessing that it would be something like that because you must have very rapid recharge to get the kind of water production you need for such a small area and a large demand.
Yeah.
And I would bet the limestone is pretty porous, maybe even karst-type aquifer, karst conditions or something.
Yeah, that's, as I said, I'm the dumbest guy in the room, so okay. I know plenty of people who can answer that, but I'm sorry.
I think we're close on that. Thank you.
Yeah. Thank you, sir. So, and I just checked my account, and no money has come in yet, so you need the account number again. I'm happy to provide it.
All right, folks. Thank you.
All right. Thank you.
Thank you.
I look forward to that. Thank you.
Thank you so much.
Thank you for having me.